All right, we are going to talk about what we call central angles and the arc measures that correspond with them. So you already wrote this down with your definitions, but let's revisit it really quickly. A central angle is an angle with its vertex at the center of the circle, and its two sides are radii. Now, I know that seems like a very simple concept right now, and it is, but it's very important that you remember the key word here is central. So it's the center. The vertex is on the center because in a couple days we're going to introduce another kind of angle that has its vertex in another location. So you gotta be able to distinguish between a central angle and an inscribed angle. All right. The sum of all central angles in a circle is 360 degrees. Okay, y'all already know that a circle has 360 degrees. So an example of a central angle here is angle ABC. Okay, angle ABC is the central angle. And it, of course, is labeled with 84 degrees angle measurement. The degree of the arc formed by the endpoints of a central angle. So it's talking about A and C here. That arc, that minor arc, is equal to the measure of the central angle. So the central angle there is 84 degrees. Then that arc is also 84 degrees. So the measure of arc AC is 84 degrees. The other piece of information they're looking for here, the measure of arc ADC. So we start at A, we go closest distance to D, and we end at C. Well, that's the rest of our circle. So if the entire circle has 360 degrees, then if we subtract the 84, then we are going to get, I think it's 276, but I just want to make sure. Yeah, 276 degrees is that arc, the major arc in this circle. And this big angle right here would also be 276 degrees. Okay, now all the geometry that you know up to this point still applies. Okay, and we're going to use some of that here in just a second. So I just want to throw that out there. We are going to need some background knowledge here. Let's look at the first example. The first thing they want to know is the measure of arc JK. So I am a big fan of tracing things out on your picture so you can see exactly what they're talking about and there's hopefully no confusion there. So that arc goes with this central angle, kind of makes a pizza slice there. So it has the same degree measure as that central angle, 21 degrees. Okay, the next thing that we need to find is the measure of angle JNM. So trace it out. Start at J, go to N, go to M. That angle, well, if we look at it, this is a straight line. K to M is a diameter. KM is a diameter. So that's a straight line. So that cuts our circle in half. Straight line has a measure of 180. So if we want to find JNM, that's 180 minus 21. So that should be 159 degrees, as long as I did my mental math correctly. That angle right there, well, I labeled the arc. The arc and the angle have the same measurement. Okay, both of those are 159 degrees. Okay, arc KL. Arc KL. So we're talking about this arc over here. That arc goes with this angle. Now what we've got going on here is we have two intersecting lines. Two intersecting lines form angles called vertical angles. Y'all remember the relationship with vertical angles? They are equal. Look at them. Don't they look the same? This angle and this angle. the angle of the 21 degrees and the angle below it, they are the same measure. So this is 159 degrees. So this arc is 159 degrees as well. Okay, my picture is getting a little crowded, but we'll make it work. Okay, so since we just used that idea, we go ahead and the rest of it. Use vertical angles with the top and the bottom there, so we get 21 degrees for the angle, 21 degrees for that arc. Now, I went ahead and did that because the next thing I need to find is arc JKM. So start at J, go to K, and end at M. So if we want to find that, it's made up of 3 pieces. So let's just add those 3 pieces together. Now, that's not the only way that we could have found that. Let's go ahead and find out what it is, and then we'll talk about how else could we have found that value. 201 degrees. Anybody have any ideas of how else we could have found that arc measure? Another way, instead of adding those 3 together, how else could we have found it? Okay, we could have done 180 plus 21. Yeah, that's 180 right there plus 21. There's another way. 360 minus this 159 over here. We've got everything but this part. So 360 minus that would also give us 201. So a lot of these problems, I can't just give you a magic formula for how to find these. There are a bunch of different possibilities. Okay, that's one thing about geometry. A lot of times there are a lot of possibilities. One final answer, but a lot of ways to get there. All right, last one that we need to do on here, the measure of arc MKL. So from M to K to L, we've gone almost all the way around the circle. It's everything but that 21 down there. So let's do 360 minus 21. Now, we could have done 159 plus 21 plus 159, but let's just talk efficiency here. What's easiest? 360 minus 21. 339. Okay, questions? Let's look at number 2. We've got one arc that's labeled with 72 degrees. Let's go ahead and label its central angle with 72. We have a central angle of 87. Let's go ahead and mark its arc with 87 degrees. Okay, now let's look at the problem. The measure of angle UXV. UXV, well, that is the vertical angle with the 72 degrees. Okay, draw the intersecting lines, those 2 diameters there, and you will see that it is across from the 72 degrees that was given. Okay, the measure of arc ST. Arc ST. Well, that is the little arc between the 72 and the 87, and I've already drawn it, but I'm going to trace it again. I have a diameter there, so those 3 together make 180. So if I subtract 72 plus 87 from 180, I will get that missing piece. (21 degrees). Mark the angle, mark the arc. That one does not have a vertical angle that matches with it, so that's all we can mark there. Okay, let's see what else we're looking for. The measure of arc WV. WV. Couple of different ways you could look at this. When I look at it, I see that I have everything else in my circle except for the piece that I'm looking for. So I'm going to do 360 minus the 72, the 21, the 87, and the 72. Now, there are other ways, absolutely, that you could do that. I think, honestly, I did it a different way in second period. That's just what I saw when I looked at it this time. Oh, there's a way easier way to do it. How about 180 minus 72? I think that's what I did earlier. Either way, you get 108. If you look at the diameter UW, we already have the 72. We want the other part of it. You get 108 either way. Okay, how about T to W? T to W, it's putting together those two arcs, 72 plus 21. So that's 93 degrees. And finally, T to V to W. So T to V to W. Couple of different ways you could do it. Let's see here. I never labeled this one over here. That was 108. From T to V to W, I'm just going to add them up. Add up pieces. 87 plus 72 plus 108. So 187? No, more than that. Woo, more than that. 267? 280. I can't add. 288. That was a failure. 180 plus, no wait. 287. 287. Still can't do it. 180. 267. Thank you. We'll get there eventually. 267. 180 plus 87. 267. Whew. Long day.